Question 15, equivalent polygons. Consider the type of rhombus described below. The formula for the area of a rhombus is diagonal 1 times diagonal 2 divided by 2. Diagonal 1 times diagonal 2 divided by 2. Now think about it this way. If we stack these up, let's say I had this shape and I just stacked it up like this. Let's say I put that there and take that one and put it up here. Okay, we get a rectangle. Notice the rectangle is going to be diagonal 1, the short diagonal, times this length, which is half the long diagonal. That's the short diagonal, that's our long diagonal. If we're looking at the area of this triangle, it's going to be base times height divided by 2. And we've got 4 of them. Let x be the length of the short diagonal, which is this or that. Let y be the length of the long diagonal. And so I'm saying that the area is going to be 4 times the area of this yellow triangle. So 4 times base times height divided by 2. Now the base is going to be half of the long diagonal. Okay, and the height is going to be half of the short diagonal. So the 4 and the 2 are going to cancel. 2 goes into 4 twice, so 2 times base times height. Now the base is y divided by 2, the long diagonal divided by 2, and the height is going to be the short diagonal, the x divided by 2. These two 2's are going to cancel, and so we have x times y divided by 2. Now that is the area of a rhombus. Diagonal 1 times diagonal 2 divided by 2. We know that the area of this rhombus is equal to the area of this square. And the area of this square is x squared. Okay, that's where the x squared is coming from. If x squared is equal to x times y divided by 2. If I divide both sides by x, I end up getting x is equal to y divided by 2. Alright, so formulate a conjecture describing the relationship between the length of the long diagonal and the length of the short diagonal for this type of rhombus. The length of the short diagonal is half the length of the long diagonal. Or I could cross multiply the 2 and say that the long diagonal is double the length of the short diagonal. 2x is equal to y. 2 shorts is equal to 1 long. Then they're saying use 3 examples to create the conclusion. So we want to see, is this true? Does this make sense? If this is true, then our long diagonal is going to be 6. But let's prove it's 6. If these two things have the same area. So the area of the square is going to be 3 times 3 is 9. So we're going to get this. Remember, x squared is equal to x times y divided by 2. We know that the area of the square is going to be 9. The area of the rhombus is going to be the long diagonal times the short diagonal divided by 2. The perimeter is 12. They're saying the perimeter of the square is equal to 12. If all around here, 4 times whatever the side length is equal to 12. So 4 times what is 12? Times 3. So each side length must be 3. That's where this 3 is coming from. The short diagonal is 3 centimeters. 3 centimeters divided by 2 is 1.5 centimeters. We have 9 is equal to 1.5. Y, divide both sides by 1.5, and that gives us 6. So y is equal to 6. Our long diagonal, if we were following this conjecture, that our long is equal to 2 times our short, would be 6. So it holds true here. Let's see if it holds true when our perimeter is 32. When our perimeter is 32, that means 4 times the side is 32. Divide 32 by 4, you get 8. So each side is going to be 8. 8 times 4, 32. So the short diagonal is 8. If the short diagonal is 8, we would expect the long diagonal to be double, 16. But let's just see if it works out. The area of this square would be 8 times 8 is 64. The area of the rhombus would have to be the same. We use the formula for the area of the rhombus. The short diagonal times the long diagonal divided by 2. That gives us 64 is equal to, the short diagonal is 8. 8 times the long, which we're not sure about yet. I think it's 16, but this is going to prove it. So 8 times y divided by 2. 8 divided by 2 is 4. So we have 64 is equal to 4y. Divide both sides by 4. 16 is equal to y. So it holds true here as well. The long was 2 times the short. If the short was 8, double the 8, the long is 16. For the third example, 25.6. So divide 25.6. That gives us a short diagonal of 6.4. And in this case, the long diagonal was 16. So the short diagonal is going to be 6.4 if the perimeter is 25.6. So 25.6 divided by 4, 6.4. Using our equation, the area of the square is equal to the area of the rhombus. The area of the rhombus is short diagonal times long diagonal divided by 2. 6.4 squared is going to be 40.96. Replace the x with 6.4. We have 6.4 divided by 2. That gives us 3.2y. 40.96 is equal to 3.2y. Divide both sides by 3.2, and that gives us 12.8. Is 6.4 times 2 12.8? Yes, it is. So it totally holds true. The line diagonal would be 12.8. This holds. The conjecture holds. And that's it for question number 15. Have a good day.